Por favor, por favor.
Muy buenos días a todos y a todas. Me complace mucho darles la bienvenida al Coloquio de Agroecología, Cambio, Climático y Educación Ambiental como parte de las actividades del Seminario Universitario de Historia, Filosofía y Estudios de las Ciencias y la Medicina, que como ustedes saben, estamos muy entusiasmados por presentar estas nuevas ponencias que vamos a tener el día de hoy. El día de hoy tenemos invitados internacionales que ahorita los van a presentar, pero yo les quisiera dar la bienvenida en el sentido de que nuestro seminario pues tiene la intención de dar a conocer este tipo de estudios y de investigaciones que tienen que ver con lo que ocurre con el cambio climático, la pérdida de la biodiversidad y la educación ambiental. Y obviamente la agroecología. Quiero agradecer de manera muy especial al doctor Arzú Rivera, quien tuvo la iniciativa de organizar este coloquio, y a Itzel Sánchez y a Brian Becerra, que son quienes nos están dando el apoyo logístico para que esto pueda suceder. Pues sin más por el momento, yo creo que todos estamos muy entusiasmados y queremos ya escuchar a nuestros ponentes. We are very happy to have you here, all of you. Please feel very welcome here at the UNAM and this university seminar. Bueno, pues le doy la palabra a la maestra en ciencias, Alicia Villela, que nos va a hacer la presentación de los ponentes. Buenos
Muchas
días.
gracias, doctora Barahona, por darnos esta breve introducción de la relevancia que tiene este coloquio. And we are going to start now to have a summary about the conferences. El primer ponente de nuestra sesión matutina es el candidato a doctorado Florent de Melesí. Él es investigador especializado en la gestión del agua en la agricultura y los impactos que el cambio climático ha utilizado como para seguir viendo la teledetección aplicada. El doctor Florent es asistente de investigación en la Fundación Federal Alemana para el Medio Ambiente. Actualmente realiza un análisis de datos para modelar sistemas de gestión de agua de riego y tiene también experiencia en la formación y mentoría de estudiantes en software geoespacial como el QGIS y en la modelización de cultivos en Aquacrop. Cuenta con amplia experiencia en proyectos de ingeniería hidráulica, activismo climático y agroforestería. Please, Dr. Florent de Melesí, it's now your time to start. Remember that you have 30 minutes, and 5 minutes before, I'm going to let you know.
Well, thank you for your introduction and your time, and thank you, Arzu and Dr. Anna, for inviting me to perform here the presentation. So today the presentation I'm going to have it's the topic of also a part actually of my PhD topic. Unfortunately, I didn't display most of the data and the results because the data are not published entirely. And since I'm still a PhD candidate, I have to, and because this is live streaming, so I couldn't share the most of the data and the results that is coming out of it. I'm Florent Demelezi. I'm originally from Kosovo, but I'm doing PhD on Institute of Environmental Sciences in Hungary at the Hungarian University of Agriculture and Life Sciences. And actually, I was really honored to get this invitation to present on this colloquium. Here you can have some of my email address for connection, and the topic for presentation today is going to be the hydrological extremes and water balance assessment at the field level using the Aquacrop model. Going straight away at the introduction, not show you any other details. My idea of the research, why I decided to go into the agriculture and in irrigation, is because I come from a country where we have a water scarce, is in a water scarce region. Here on the, I will go straight away to the image because it will show a different perspective. For example, where I did my research, where it's in Hungary, as in Europe, we have the perspective. We had the possibility to have some measurements where we're applying the irrigation system. So when it's coming to we are doing the observation for the climate change and climate mapping, we can have different perspective of what is going to be the agriculture production. But when we are considering the data from the different years, we can see that, yeah, in a way, the irrigation is helping the agriculture production to be increased. But what we are applying and what are the possibilities of irrigation is it is a different thing. So another aspect that I consider during my research is the water accessibility and water scarcity on excess on water, which could possibly decline the crop production and the plant health. Why I inserted here this sentence is, I think, important because many farmers maybe are lucky to have their fields around the rivers, or around their wells where they can irrigate. But some of the farmers that are found in a bit more faraway regions, they might not have this possibility. So for them, it's a bit difficult to irrigate this field. So another part is of my research is in identification of the time series gap analysis of the irrigation scheduling to provide advice at the regional level for the irrigation management. Apart from this, this is in a scientific perspective. So I'm using for my research, I'm using the AquaCrop model, which is an FAO model to model the crop growth of the crop of winter wheat and maize in Hungary, when we have, for example, the possibility of applying irrigation or not applying irrigation, and how we can improve furthermore. About going to the literature review, here I displayed some of the research papers which are a bit more simple. So a research of Jin in 2014 found that the model AquaCrop accurately simulated winter wheat canopy and the biomass. The wheat canopy cover, biomass and grain yield in the North China plain, while Sala in 2019 further validated the model performance in assessing rain-fed maize using satellite-derived fraction vegetation cover. So here we have two different cases. For example, Sala and other researchers, they modeled using the crop growth for example, in China, or I can go in all of the continents. What so far I didn't find a research paper that did the research in, for example, in Austria, which is, I would say, but the model was simulated in different countries. Currently, there are web-based version of the AquaCrop model, which you can simulate the growth, but also to have a really good validation and calibration of this model, you should have a field data. Another research paper that I will mention here is the evapotranspiration measurements, which started from the Penman-Monteith big leaf of the Allen in 1991. The big leaf model of simulating the crop, the evapotranspiration, no longer stands. Why is this? Because with this concept, the whole agriculture field was considered that is growing. But with the AquaCrop model, we can do the simulation as a point-based analysis, which is more accurate because it does supply it in a way a bit more accurate and a bit more representative of the model on the point-based analysis. Here, in the sub in 2021, it demonstrated that a successful canopy cover extraction from the NDVI to the AquaCrop model to predict the wheat growth in a Mediterranean environment. This paper is really important for me in a way to mention here, because my country, even though the research has been completed in Hungary, I think that it's important to mention that I'm extracting the data, and this one I can model with this model also in my country as well. Another way to consider is the Hungarian agriculture land faces several challenges related to soil quality and management, with a research paper of Pastor in et al. In 2017, and also Koshareves accurated the prediction of a soybean yield and canopy cover using the water efficiency under different irrigation and strategies. Which also this depends that also this researcher uses different field parameters into the field to model with aquacrop. Another research paper of Kopek which is more focused on the soil parameters of the modeling. It does say that the conservation tillage can result in equal or higher or lower yield compared to the conventional methods. So in this way, we have really a mix of high parameters that we have to consider when we are considering the yield of the agriculture production. But the importance of what I try to summarize with these very different and apart and a huge spectrum of these research papers is that with the aquacrop you have everything into one as a model, and then you can extract the important data out of it. So here you have a little bit of the aquacrop model. So the aquacrop model is a robust model for simulating crop growth and water requirements over different vegetation periods. So, and also on the graph here, you can see what of the parameters you will need to import into the model. One thing that is important here to mention is that if you are missing some field data, you can use a base model of the aquacrop available data and then import them into the model. Another way is that the aquacrop model, sometimes it doesn't require, for example, having a time series of the data. So therefore, if you're doing a research on specific crop or a specific location, you can extract data from another research paper or another, how to call it, a third party data, and then you can extract those data into your model and then do the analysis. So for example, in the climate, you will need maybe at least 4 or 5 parameters, which is important to, which in this case you can calculate them using the ETO calculator if you're having the minimum maximum rainfall and CO2 concentration for the evapotranspiration. For the crop, you can have a calibrated and validated crop characteristics from the data bank, or in this case, for my research, I have my own data. And also at the end of this part, you have a part where you can implement irrigation management practices, where was my focus of my research. So the research objective of my research that I'm doing in Hungarian Békés region is to simulate the field measurements of the canopy growth of winter wheat and compare the results and model outcome to assess water balance measurements modeled from the combination of in situ and calibrated data, and to assess the accuracy of soil moisture and harvest index. And all at the end is in a way to improve the model workflow of the score data by combining and supplying the data with remote sensing data. So this is my main research objective, is in a way to combine my field data and to have a simulation accuracy, or to have it, or in a way to call it a base map results, so we can use in the future or maybe the farmer can use it so he can simulate the irrigation accuracy for his field. The research sub-objectives are to monitor the crop growth and biomass production of the 2 main crops in Hungary, winter wheat and corn, or also you can call it as maize, to improve the measurements model for the biomass production and management with the help of satellite imagery integration into the model for the crop management. Yeah, into the second one, the sub-objective, I would like to add that there are 2 ways we can import this data into the model. In the programming part of the aquacrop model, which is easier to work on because you create a database of the data, and then you simulate based on those results. It is harder to import this data. So in a way, you can make a comparison analysis or compare the canopy growth of the model. While in the GUI version of the model, it is easier because it actually has another platform where you can import these data. Another part is to have another sub-objective is to have a comparative analysis and the validation of the vegetation indices as a parameters, integration into the crop model input to study the crop water balance. So in the irrigation efficiencies here, I moved in this sub-objectives, I moved only more focusing on the deficit irrigation. So basically, the farmers can have the available water at his hands, but what I'm planning, I'm trying to implement here a deficit irrigation because maybe the farmer will get a higher balance, but the economical value and the environmental impact of using the maximum irrigation to have the maximum yield is negative for the environment. And at the end is another sub-objective is to provide an irrigation accuracy information and support the system. My also here to mention is that my research is part of the European Space Agency project, where we try to implement the aquacrop model into the web-based support system. Now there is a small startup in Hungary where they created the aquacrop model, and they create a kind of irrigation accuracy information support system, and they implement this one for development of irrigation scheduling, yield-based assessment, and crop growth. Coming to the materials and methods, for the model of this simulation, I have used is FAO aquacrop model, which is developed in, I think, 1993 or 1995. And the location of the research is in Sarvas and Mezőkés in the Békés region. If you can see my mouse, it should be in this part here. The data that I collected was for winter wheat, maize, and the field observation for the crop growth of the vegetation parameters. Another way is I had soil texture, soil moisture, temperature, NEC, and also the yield measurements of the model and the sentinel data. Here you can see the plots where how I planned them. So the squared this one, the corn plots are for maize, while for the wheat I have only for 2 years of data, and for the third year where I'm doing the validation or in different plots. In the graph one, you can see the monitoring time from 2021, which I started for wheat, and then for maize in Mezőkés, and the location of the plot analysis. So on the research question that I'm going to answer, hopefully I will be happy to invite you on my final presentation of my doctoral thesis, is how does aquacrop workflow and optimal parameterization with the supplementary data help us to provide insight on how to improve the water balance at the field level. This is, of course, done only with the use of the aquacrop model. Also, I can mention that there are also different models that are based in meteorological data or based on the field data, or different metric and the field data that you collect, and how satellite imageries with combination of meteorological data improve the water balance model, and what are the significance of time series to develop and implement adaptive irrigation strategies that I can optimize with crop health and the yield performance under changing climates. Another part of the research question is that what information time series analysis of the vegetation growth and aridity provide effects on the yield. Here I am going to test which of the Earth observation or Sentinel-2 indices are going to be more suitable for the analysis and integration into the aquacrop model. So currently I'm working with the NDVI, but also the ABI showed a quite high accuracy or crop growth monitoring of the crop growth of what I monitored on the field, while the other parameters that are done is the soil moisture and canopy cover I did with the field data or the handheld devices of the measurements, while the evapotranspiration I'm measuring are based on the meteorological data system that I have the data collected. So here is a research workflow, initially what I planned and the final version. I have it here. So yeah, sorry. The steps is the basic part is like basic data preparation and field data collection, the Earth observation data preparation and the validation data. So first I have first when I'm doing the modeling into the aquacrop model, I have prepared a baseline model, then I modified based and then on the field data, and then I validated based from using the data from the yield observation on the field of those plots and using the statistical office of the Hungarian office that collect the data for the field. So the idea is simple. Is what I can do is what is a bit more difficult with aquacrop is to have a clear data cleaning, because whenever you are adjusting the crop growth of the by the model, you're gonna see there is like a high deviation from the reality that what I measured. So so far I completed the black box, the green box, and now currently I'm working on the results of this flow chart or the research workflow. Here I have the soil and soil moisture data. So the research paper for the aquacrop simulation is currently on the preparation. So I'm working on those data. Here on the graph one, I have a data displayed from using the meteorological data from Sarvaj, where I'm doing the simulation into the aquacrop. So here we have currently even though in actually 4 to 5 years a growth of actually the elevation of the soil the weather station data trends over time, we have a slight increase on the temperature during the year. Especially we had highly warmer temperature on the 2022, where we saw a really drop on the yield, which is important for my research to have a really extreme, but also it does not look good on the graphs. And here on the wet soil moisture, I have all the raw data from the data collection that I did so far. And here I also added the soil moisture profile because in Hungary and different regions we have different soils. For example, in Hungary, we can find mostly in the region of the clay loam and loamy soil, or depending on the location or where the farming is done, the available water content can be changed. So this is also important to have known when you are doing the modeling into the whole crop, because it can highly deviate from the actual reality of the soil moisture on the measure. And also the bulk density on the model that I'm working is from 1.18 to 1.26, which are done from the data are provided by the institute I was working together with. And here are also provided the aquacrop simulation, the canopy growth, the emergence amongst canopy and senescence. So when I'm applying, I'm doing the simulation with aquacrop. Here are displayed the canopy cover growth based on the aquacrop model. So here I have 9 samples from the model that I simulated, and most of them the data are similar, so there is no much significance. What I'm going to compare this data is with the NDVI. So of course, in the future there should be significant differences with the data. So, but also so far there is a high correlation with the NDVI and the canopy cover, which is simulated. So this is also important and good for my research, because it does provide high accuracy. So I didn't mention these. The data for the NDVI are provided by the Sentinel-2 data from the Copernicus service. The NDVI is calculated with using the near band and the red band, while the canopy cover, which is calculated by the aquacrop, is actually in a way can be derived by the NDVI, which is used the minimum and maximum NDVI in a same report, actually fraction by the NDVI formula. And the research base here, I have an also comparison of Sentinel-2 and the NDVI with the field measurement. So the spatial resolution of the Sentinel-2 is 10 meters, which you can downscale it from 30 to 10 meters actually. So, and the temporal resolution is 5 to 17 days. What I did for my research is that in those 2 years of field data monitoring is I looked forward to do the field monitoring whenever the Sentinel-2 was passing in the same date and I was doing the measurement, of course, if the weather allowed. And also, the good thing is to use the Sentinel-2 is because it has a higher accuracy. Also, there is a deviation and the noise on the satellite, but it can be used here. So on the blue box here, this is the time frame I'm focused for the research and modeling. This is on smooth time series. Wherever I'm applying the smoothing techniques, then the correlation, there is a high correlation between the green canopy cover, which is derived by canopy cover derived by Sentinel-2, and the aquacrop model. And also here I have another, I wrote here as issues because, for example, here in the case of maize 16, even though I did removing by the processing the Sentinel-2 data, I removed the class on it. There is a high possibility that there is something wrong with the pixels, and it happened here. For example, in the 2 cases, I have a really low NDVI, which is not common and it's hard to define. So also, even though you are, for example, applying and you cleaned all the data and you did the modeling in a good way, let's say there is also possibility that the Sentinel-2 images can be, especially in the places where I'm monitoring, there could be clouds which are not detected by the algorithm, and therefore it could be that you have to do the manual looking of the data that you are using for the modeling. And here I'm reaching at the almost to the end, the yield analysis. So in the model, for example, here this is the sensitivity analysis in the wheat. So if you're looking on the green table, this is the date where the farmers reported that they start the planting of the wheat, while on the other side, on the 22nd of April of each year is reported kind of which is the date of the farmers are applying or applying the seeding of the seeds. So what I did with the simulation with the validated model is I tried to add a couple days forward or backward to see what is the difference in each of these crops, to see, for example, if we can tell the farmers to plant earlier or later in the year. So with the utilization of the model, we in a way successfully yielded an average yield of 2.9 to 6.59 tons per hectare for 2022, while the higher yield for 2023. As I mentioned before, in 2022 there was a high drought period, so there was no rain for at least 3 months in the places where I was doing the modeling. Actually, the field data collection. So this is why we have, but what we have seen that also the crop productivity ranged based on the eco crop ranged from 0.6 to 3.9 kilograms per cubic meter. So also we have it here that if for example, if we can plant the wheat in 15th of October, it shows that we can have a higher yield. So maybe in the future, if we can, for example, we are consulting with a farmer, we can tell him that based on the weather conditions or if the farming time allows, you can plant it earlier because it might provide you a higher yield. This is also, of course, depending on the weather forecast, so it will depend on it. So an early sowing could increase yield by 560 kilograms per hectare, compared if you are planting, for example, on a 3rd of November, where some of the farmers also reported that they could do the planting, which I found this data from the reports. While for the corn, the baseline is 22nd of April, which is driven in by the extreme outlier in 2021, which was 9.5 tons per hectare. But for the corn, this was not statistically high, a high difference on the yield. So there, with this we can conclude that maybe the farming techniques at the later stages are more important than changing the planting date. During my research, I was also interested in working with the web apps. So here you can see that while I was doing also a fellowship in Germany, which was founded by Deutsche Bundestag Umweltung, I developed this web app where if you would like to have a look at it, you can scan the QR code. While the idea of this web app was in a way to provide as a subsidiary a way to run a crop model. So, for example, if you have, or in case I have the validated model running into the crop with only field data collected. Actually, this the raster that you can see is the elevation model, but also this one uses the Lucas database, which is a topsoil survey by the Earth European Soil Database monitoring. So I use the raster on the web, and then here you can see, for example, where is the location, the latitude, longitude, elevation, available water content, ball density, clay content, coarse fragments, and sand content, and the silt. So with this, also into the aquacrop model is really important having accurate soil type, because if your model is running, for example, in a clay soil, and now you're going into a northern region of Hungary, and there is a clay soil, if you're having a different soil, then your model will act differently. Also, this is the aquacrop model takes into account many factors, so therefore it will provide a very different results or different yield outcome from the model with this one. So
Sorry,
this is
but you
one of
have
the
5 minutes, Florence.
Yeah, I have 2 more slides. So with this one here, this one also uses the Google Earth hybrid Hungarian border and USGS elevation and the Lucas database for the soils. So and here also, because I started learning using Google Earth Engine, and then I found it really for Hungary. I did it all as well, but I wanted to show in a way that you can also use it, which is super easy, especially now with the use of the AI or like ChatGPT. You can generate location-based analysis based on this one. So here I displayed the Kosovo land cover map with the use of the European Space Agency land cover database. So whenever, for example, if you want to see an historical web view of the location, then you can use this map to look at the location of this one. So here are some references for my research that I used. So more important, I would mention is that the Allen researches, which are based on the FAO irrigation and drainage paper, but also on the crop transpiration aquacrop model and the crop parameterization model, and also some other research paper that you can find. So, well, thank you for your attention. This was for my presentation.
No, thank you, Professor Demensi. We are going to wait at the end of these talks for the questions. Now, yeah, we are going to talk about next exposition. Next talk is Professor Joseph Gembelim. Welcome, Professor Joseph Jombeli. How are you today? Nice to see you again.
Matt. I wanted to
Yeah, we are very happy to have all of you today in this colloquio that ARSU organized. Thank you, Florian, for this interesting talk that you gave us. Now, the second talk is about soil management and rural resilience. And our conference is Joseph Jembeli. I'm going to give you a little summary of his work. El profesor Joseph Jembeli es profesor honorario con más de 34 años de experiencia en investigación agroecológica. Actualmente es director del Centro Nacional de Investigación para el Manejo del Cambio Climático y Tierras Regionales de la Universidad Húngara de Agricultura y Ciencias de la Vida. Cuenta con una amplia experiencia en la dirección de proyectos de investigación. Es un miembro activo en redes científicas en Europa Central y en colaboración con universidades de la región Visegrado. Su investigación se centra en el desarrollo de métodos de protección de suelos agrícolas adaptados a las condiciones de la Gran Llanura húngara. Su trabajo se ha centrado a la mejora de la gestión de agua, el manejo sostenible del suelo y la mitigación del estrés abiótico en cultivos. With us, Professor Joseph, you could start now. You have 30 minutes. We will let you know 5 minutes before you to finish. Thank you and welcome.
Yeah, thank you very much. Greetings from Hungary. So still good morning in Mexico, but good evening in Hungary.
Yeah, it is 10, we are at 11 in the morning.
Yeah. So first of all, I would like to thank you for the invitation. It's a big honor to me. And as you mentioned, this is the second chance I can take part in a Mexican conference. In 2022, I had the chance to visit your beautiful country, and I visited UNAM, and I gave some presentations there. And secondly, I would like to express how proud I am because Florent was my master student some years ago at the University of Debrecen. And I have to mention Arzu Rivera, Dr. Arzu Rivera Garcia, who was my master student and later my PhD student. And he successfully defended his PhD, and we have been working together for more than 6 years with big success, I think. Okay, so to my topic, I hope that the English title is the same as the Spanish. For me, the Spanish seemed to be a little bit longer, but it doesn't matter. I am also from the Hungarian University of Agriculture and Life Sciences. Formerly, we belonged to the University of Debrecen, and my topic is about the soils of Hungary. And I made a note because Florent mentioned Hungarian arable lands face several challenges related to soil quality and management. And this is what I would like to talking about, and maybe I can highlight some solutions how we can solve these problems. So contrary to Mexico, Hungary is in a much lower elevation, not above 2,000 meters above sea level. And here is Hungary, and maybe you can see my cursor. And it is laying in a basin. We call it the Carpathian Basin because it's surrounded by the Carpathian Mountains, and the elevation is only 70, 80 meters above sea level. And this basin characteristic determines a lot of things in Hungary: the soils, the climate, and the hydrology as well.
Professor, I think your presentation is not changing.
Not changing. I can see it very well, but I don't know why.
We are still in the soil management and rural resilience.
You can see my presentation because I can see it in full screen.
The microphone, yeah, I think you have to change
change
it
the
manually.
icon that is on the bottom of your display. At the bottom, use the one that the first one, that one.
Yeah, but I did it so far, and I can
Two
see
times? Did you do it? Do
two
it
times.
again? Do it strong.
Yeah, but I can see in a projection mode.
Okay.
And you?
We just see the before the
Not
display. So maybe you can
Maybe just don't use the full screen, just as
yeah,
a slide.
And this way?
exactly. Yeah,
You
better.
can
Like
see?
this.
Okay, so we remain with this version. I can see with a full screen projection, but okay. So back to the Carpathian Basin now. Maybe you can see the how Hungary is laying in the Carpathian Basin, and I mentioned that it characterizes a lot of features about the climate and the soils as well. And I mentioned that. And Florent also mentioned that we have a lot of challenges in terms of soils. And the basic problem is soil degradation. So the status of our soils are not really good. One of them, especially in the eastern part of Hungary, we have heavy textured, compacted soils with high clay content, and we can hardly cultivate them. Even we call them minute soils, which means we have only 1 minute to cultivate our soils in an optimal soil status. Because if you cultivate your soil when it is too wet, it's harmful for the soil. If you cultivate it when it is too dry, it's also harmful. So that's why we call them minute soils, these soils. And you can see that we have extreme hydrological situations. So on the same field, we can suffer from drought in summertime, and within the same year, for example, in early spring, we have excess water and some inundations on our soils because of the low infiltration rate. And here you can see one of my colleagues who is not so strong, but he just pretending he could fold deep loosener, but it was not him, it was the soil. And the other main agroecological feature is, of course, the weather and the climate. And we have quite a lot of extremes, and especially due to the climate change, which is manifested in the higher frequency of weather extremes in Hungary. I just want to highlight the trend during the last 20 years. You can see here that the trend is increasing in terms of annual mean temperature, and it was around 10 centigrade annually, and recently now it's more than 13, which is a huge difference. I think you know it. And on the other hand, the annual precipitation, the average is like 500 millimeters, but you can see the huge fluctuation within the years and the decreasing tendency. And I have to mention that in such a year like in 2010, like it was almost 900 millimeters in such a heavy texture soils. Of course, with a low infiltration rate, this amount of water is even harmful and not available by the crops. But the main point here is the huge fluctuation that you can see even within the last 20 years. So what we can do, of course, we cannot change the environment will never accommodate to us. That is for sure. So we have to accommodate to these agroecological conditions. But of course, we can agree that we cannot change the climate, but maybe we can partly change the soil conditions. So, as also Florian mentioned, that our soils are not so healthy at the same time at this time, and they suffer from unfavorable physical, chemical, and biological status. So we have to cure our soils, and therefore I always teach that maybe we need or we would need more soil doctors. We train even plant doctors and medical doctors, of course, but there are no soil doctors, but we would need them, I am sure. So my parents were medical doctors, human doctors. So maybe this is the, the, um, the origin of the idea that I said that soil doctors have the same principles as in human medical service, and I want to prove this to you. So in human medical service, we go to medical examinations. In our soils, we can do in situ measurements. We can measure the actual soil moisture content like a thermometer. We can use it like in a human body to measure the soil moisture content. We can measure the penetration resistance, for example, of the soil. We can take soil samples, undisturbed soil samples. We can measure we can quantify the microbiological life of the soil. Maybe you know that there is a close correlation between the carbon dioxide emission and the microbiological activity of the soil. And here you can see in this photo, in the right up corner, Arzu is measuring carbon dioxide concentration with my younger son, who is also an agriculture engineer. In human medical service, there is sampling of blood, and they analyze the blood. We can take soil samples and we can analyze them very precisely. I think the analytical capacity is very high recently, and we can have very accurate data to see how healthy or sick our soils are. In human, the human doctors write prescriptions. We can make an experimental design, and we can test different the medical amendments. For example, the soil doctors can use these different schedules and for different experiments. And so what I want to highlight is some curing of our soils. In human medical service, there is medical treatment of people in soil. We have agrotechnology in our hands that we can manipulate our soils through soil cultivation, soil reclamation, soil conditioning, organic matter input, or even irrigation. And among these, I would like to highlight two: soil cultivation and soil conditioning, because we have no more time today. And I would like to highlight some results we achieved during the last few years. And the soil doctors can also use medical treatments like chemicals, nutrients, conditioners, and biostimulants. And here you can see Arzu just doing his experiment at the Kartsag Research Institute with his lysimeters based on his own idea. That was the basic of and the principle of his PhD dissertation. So one tool is in our hand is the tillage, the soil cultivation. Maybe you heard about different tillage technologies like no-till, ridge-till, mulch-till, zone-till, or strip-till, reduced tillage, and conventional tillage. The last two, what we have experience with, conventional tillage, you know that it is based on the turning of the soil. We use plows to plow the soil, and here you can see that it is full rotation of the soil, the subsurface soil. And contrary to that, in reduced tillage, it means shallow cultivation. Reduced tillage means reduced number of tillage operations. We never plow the soil, and we leave the crop residues on the soil surface. Basically, these techniques were invented in the United States of America in the 1950s to mitigate the harmful effect of soil erosion, water erosion. In our fields, in our land, which is a flat area, we don't have to fight against water erosion, but we found that there is another another favorable effect of reduced tillage, and I would like to highlight this later. So the medical treatment, option one, is tillage. You know that the water balance of the soil, the moisture content of the soil, is determined by the infiltration rate of the soil. We have to take into account the water inputs, and of course, which can be irrigation or natural precipitation, and the evaporation. And we lose the moisture content from the soil, and these two processes are basically determined by the soil structure. And how we can change the soil structure? By tillage, by soil cultivation. So this is the principle. So in the 1990s, the former director of the Research Institute, Professor Neri, initiated a new experiment. You can see the aerial photo of that here. And we started to cultivate these lands without plowing, only applying reduced tillage. And we compared these treatments with conventional tillage. So the hypothesis was that conventional tillage can be prospectively replaced by reduced tillage. Why? To stop or mitigate the soil degradation, to improve the physical, the chemical, and biological status of the soil. And if we have a better soil status, we should maintain this improved soil status. And how? In a cost-effective, soil protective, and soil moisture preserving way. So that was the most important part, not the combat against water erosion, but to keep as much moisture in the soil as possible. Oops. So maybe I don't go into details, but the principle of this reduced tillage is the mulch layer. I mentioned you that we leave the crop residues on the soil surface or shallowly incorporate into the surface layer. And this way we have an isolation layer called mulch, which reflects the sunlight, so can keep the soil cooler and mitigate the evaporation loss from the soil. But rainwater or irrigation water can still infiltrate into the soil. And on the other hand, this mulch layer ensures an organic matter input into the soil, improving the structure of the soil. So when we started this experiment, parallel with the field experiments, we started to simulate these tillage operations in lysimeters, in weighing lysimeters, which are very good tools to determine the water balance of the soil. We have a lysimeter station with 6 weighing lysimeters, and my doctoral thesis was about this topic. Here you can see some surfaces of the lysimeters simulating the normal seedbed after plowing and some other tillage operations. This is an untouched, untreated soil, and this lysimeter, on the surface of this lysimeter, you can see the mulch treatment, which is simulating the reduced tillage. And by means of the weighing lysimeters, we can very, very precisely determine the differences in the water balance of the soil. And some results. Here you can see the evaporation loss from the lysimeters in terms of the water input, in the function of the water input. And if we have conventional, conventional is this pink or lilac curve. You can see that especially with the shortage of water, in the case of shortage of water, there's a much higher evaporation rate. The untouched, the bare soil has the highest evaporation rate, of course, because there is no chance for the infiltration of the water into the soil. And by means of reduced tillage, we can strictly decrease the evaporation loss, especially if the soil is dry. On the other hand, I mentioned you that the mulching, crop residue management is also good for good as a organic matter input. So therefore, we compared conventional tillage to reduce tillage in terms of the microbiological activity of the soil, measuring the carbon dioxide emission. And here you can see 6 years of the results of 6 years. We measured the carbon dioxide in stubbles when we could exclude root respiration, just pure microbiological activity could be determined. And you see that every year reduced tillage had a higher microbiological in the soil. The reduced tillage had higher microbiological activity. And of course, the farmers are more interested in the yields. From agriculture point of view, of course, it's more important for them. And we compared different crops in different years. So these are the averages of several years. And you can see that reduced tillage is the green one. It's always higher compared to conventional, except for sunflower. This is, sorry, it was in Hungarian, but it's wheat, it's corn, it's sunflower, it's fodder peas, millet, and winter barley. Somehow, sunflower doesn't like reduced tillage. We don't know why, but we have time to discover it later. Another medical treatment is possibility is soil conditioning. The main goal is to improve the physical, chemical, and biological status of the soil. And we found after 6 years of application of a soil conditioner that we found that the thickness of the humus layer with good structure was deepening down to 20 centimeters from the original 10 centimeters within 6 years, not from 1 year to another, as the dealers always say, but it takes time, but we have positive effects in this respect. And of course, if we have a better structure in the topsoil, the moisture content of the soil is better. In the same lysimeters, we had the same water input, but you can see this is the soil moisture content, the soil moisture stocks in the soil at the depths of the 20 to 30 centimeters. And this curve shows the untreated control. And if we used a certain soil conditioner, we had the highest soil moisture content in the soil. We also measure the penetration resistance in the control plots, and no application of soil conditioners. Penetration resistance is much higher than in the treated soil with a soil conditioner. We also had a chance to measure the traction power demand, how much energy is needed to cultivate the soil, to pull, for example, a plow or another tillage tool. And here you can see that along the plot, in case of the treated plot, lower traction power demand was characteristic to the soil. And by soil conditioning, we can increase the microbiological activity. Here you can see a treatment. You can see this is the first treatment of the carbon dioxide emission was quite high, but then it was lowering. And the second application of a soil conditioner, it was higher again. So in terms of biological status, we can improve our soils. And of course, farmers are more interested in the results. This is the combination of tillage and soil conditioning. Here you can see the conventional tillage results. In the condition plots, it is also the average yields of corn for 6 years, 6 years average. And the untreated was lower in case of the reduced tillage as well. But in the reduced tillage, we had much higher yields. So the combination of reduced tillage and soil conditioning had the best result. And you can see the difference is quite big. The other medical treatment, which is a little bit different, the last one is plant conditioning, which is just an acute medical treatment. It has no effect on the soil, but under our changing climate, to mitigate the stress of the plants by UV stress, heat stress, salt stress, whatever, drought stress, of course, we have good results. We have an experiment where we treat grassland with plant conditioners, and we have positive results. Here you can see compared to the control, untreated control, in case of the application of different plant conditioners, we can increase the yield and we can elongate the vegetation period, which is very important in terms of grazing. And the conclusions, finally, application of soil protective tillage, like reduced tillage, has positive effect on the soil structure, soil moisture regime, the soil temperature regime, soil fertility in a cost-effective and environmental-friendly way. The application of soil conditioning has positive effect on the soil structure, soil moisture regime, the soil compactness, the microbiological activity, and soil fertility and yields. And application of plant conditioning has positive effect on stress tolerance of the crops and the yields. And just some personal remark at the end, when my wife asked what I teach and what I'm talking about in such conferences, and I explained her what I'm dealing with, and she said exactly this in Hungarian: what's good for the soil is good for the plant, but what is good for the plant isn't always good for the soil. And I translated into in a more scientific way, and this is my interpretation: healthy soil makes healthy plants, but not everything that helps plants helps the soil. And this is my closing slide with the word clouds of the keywords, and thank you for your attention.
Thank you, Professor Joseph, for this interesting talk. And we, as I mentioned to you, we are going to wait at the end of this conference for the questions that we are receiving from the public. Our next talk is Dr. Rihem Fered Eli Mohamed. I didn't pronounce this very well, I'm sorry.
No problem.
Welcome, Professor Rihem. Is Rihem? How do you say? Rihem? Oh, okay. Rihem Fared es la profesora Rihem Fared. Pertenece a la Universidad de Heliópolis. Es pionera en malacología y protección vegetal. Ha desarrollado una visión vanguardista e innovadora que hace referencia a lo que trabaja en Egipto. Se destaca como miembro fundadora de la Facultad de Agricultura Orgánica en la Universidad de Heliópolis. Es la primera en su tipo en Medio Oriente y Norteamérica. Desde el 2018 ha impartido 13 cursos. Su innovación en estos cursos es la vinculación de los objetivos de desarrollo sostenible en la educación agrícola con una visión de lo que sucede en Egipto para la Agenda del 2030. Es una mujer muy líder que se ha centrado en el desarrollo educativo y ha colaborado de manera multidisciplinaria, participando activamente en diferentes proyectos que fortalecen la extensión agrícola y la construcción de capacidades para enfrentar la crisis climática global que hoy en día padecemos. Su labor integra la agroecología, la respuesta al cambio climático y la educación ambiental en la formación universitaria. Welcome, Professor Riham. It's a pleasure to have you here. And you have 30 minutes for your talk. And let us know if you are ready.
Okay, thank you so much for the lovely invitation, and muchas gracias to you, to Arzu, my good friend that I met him in 2015, and thank you so much to Dr. Anna as well, and for everybody in the Mexican team. Good evening for the Mexican team, and good morning for the Hungarian team, and also good evening for the Hungarian team, and good morning for Mexican team, and also good evening from Egypt to everyone here. Yeah, thank you so much for the lovely invitation. And let me start now for my presentation, which is mainly focused on the agroecology and the climate resilience in training module on sustainable crop protection and agriculture biodiversity. Because in this time, we are focusing how to implement the agroecology principles in the module system and training, and to give them like a classes and lectures or seminars to give to the students how much this topic is really important. Next, please. So as you can see, we have a universal or global SDGs around the world, which is the R17. And one of them is really concerned, which is SDG number 15, life on Earth, which is really focused about every single organism that are found on the Earth. And also like a concern about sustainability. I care about agriculture. I care about all the living organisms. Also SDG number 1 and number 2, no poverty, and also to concern about the organic agriculture. They are really important for the people. So next. You can see here, we want to implement the principles of agroecology in our training or our modules and our education system. So you want to transform them from just being in the classroom, just to listen, and the students only just listen to you. You want them also to interact with you and to have like hands-on learning or hands-on experience, and also to foster the collaboration between the students and between the facilitators or the professors at this time. Next. You can see in this slide, okay, you want to transform the education system, not just only to be in the classroom. You want to take them and put them in the farm. And in this time, you consider the students, they are the learners. So you don't only just want to change their title, you want to change their mindset from just a student, he just a passive guy, he just only listen to you, he does not interact with you, but you push him through a different kind of educational system to turn from student to learner. And my role now as a professor, I'm not a professor or instructor anymore, I'm here to facilitator. I want to push my student to think more, to interact with me more, and also to increase their imagination and to increase their behavior and performance inside the farm itself, to interact with every single organism and to interact with every single plant they have found them around them. In the beginning, we have like only one module, which is focused on the biodynamic moduling, and we transfer them from one module to six, because to 6 modules. I mean, like after multiple years of working and multiple years of make the program or progress to the program. Okay, from one module, we make it to 6 modules. Next. You can see in this slide, like we have in agriculture, in Faculty of Agriculture, organic agriculture faculty, we have for sure 4 years to be graduate student. So as you can see, you have a like in the first semester, we focus in soil. So we focus here in just the soil structure and the soil health. In the second semester, for the same group of the students, we focus this time on plant, what the difference of plant, the taxonomy, the classification, the characteristic of the plants, and how to make the difference between them, and also how to identify them. Then we move to the animal, the importance of livestock husbandry in the farm and how they interact in the farm with the farmer, and to increase the yield production of the farm. And the next, nutrition, and this time we focus about the health of the environment and also the health of the people themselves, because as we know, we want to reduce the use of the chemicals or fertilizers. For that, we have to think more about our food and our nutrition, and to reduce using of these hazards to have an healthy food and healthy environment. So, and we come to the third grade. So we have economics, because also we have a part of our agriculture. We have economy of agriculture. We need to focus on this module. And the last module, it's become the agroecology. So agroecology, it's become the last module. We spend like a whole week in the farm, maybe from 10 to 15 days. It depends about the practices they're doing or the activities they have. So I make the students, he or she completely inside the farm, interact with every single part of the farm, and away from the classroom and away from the lecture room. And he make this feel like is like a holistic approach with all the organisms he surrounded us. Next. So one of the successful examples that we are working here, and you can see here, this is our students of HU, Heliopolis University. They are working in like a training module on the principles of organic agriculture and also the principles of biodynamic agriculture. And this program combined between the theory and the practical part. And we focus about the farm like one living organisms, and also promoting the sustainable soil management, the biodiversity, and how this make this kind of farm like a one cycle. They are working together to make the benefits of the environment. Next. This is a lovely picture, which I love it. So in agroecology module, as you can see, maybe this is my picture with my students in 2018. So we start so early from such a long time. And all this time we are working on to make more improvement for the program and for the training, how to add more activities and how to add more interaction with the biodiversity of the land. And this is our last picture, 2024, last year for the agroecology module. And very soon we will start our agroecology module in November. So we're gonna miss the picture of 2025. So very soon we're gonna start this and we add it to you. Next. So, and this time we should think about what the kind of toolbox that we use and what kind of competences we should think about it. So if you want to make activities with a student, you have to think in a different way. It's not just only your role as a professor to say a lecture or to say a seminar and the student also only listening, but also he have to interact with you. He have to talk with you. He have to listen to you. He have to discuss a lot of things and also give you reflection. Does he understand all this kind of things or not? So the toolbox that you can see in this slide is support the teaching participant and how to implement all this action based on education, and how to make a focus on the training and to develop all his skills to make it in a good way. Next. So can you see here now the core competences we can see now? So the first one is the observation. Second one is participation. Third, visioning, reflection, and dialoguing. Okay, you can see them is really very normal behavior or very normal performance the student should be note. But unfortunately, to talk to the student and to make him really observe the difference between the plants, or make the difference between the animals, or the difference between the different kind of organisms he has surrounded him, it was really hard task to make him just observe. Okay, not only, and also, a lot of students, they are shy. So to make them participate with you and talk with you and ask freely a lot of questions and interact with the activity, it also was really hard. Then visioning, and you also waiting for their reflection. Does they understand what you're saying? Does they get the point that I want them to know? Or does they understand what's going on around him? Dialoguing with them in the end, it was really important for us that to make sure that they understand very well what we are trying to say and what they want them to learn from that kind of module and training. Next. This is the competences that we're talking here. So each one was really essential. After a long time of studying and a lot time of like workshop and trainings between our professors, or like it say it in a good way, facilitators. So we found that this competences was really important, and we have to implement them very successfully in the education system, and preparing our graduates to have this kind of competences to understand what's going on around them in the farm. Next. So here more activities and more principles at Second Farm. I love this fair. I like this picture because as you can see in this picture, our students now implement so much inside the farm. They do their planting the seedlings by themselves. So we make them like they're touch the soil by themselves. It's not just a dirty thing. No, it's a very important component for the environment. And when we talk about the soil health and the soil structure or the soil nutrient, this is really important topic. So we want them to interact a lot with this kind of organism or this kind of substances. This is important for the environment. So this picture mean a lot to me when I feel completely sure that they interact with the environment by themselves. So there's no barrier between them and between the other factors in the environment. Next. So to interact with them, so we can see here, like as they provided like a training for them, and we can see this kind of biodynamic course, and not also dealing with them. We have to make them express about themselves. As you can see in the first picture, a lot of our students now, they express about their feelings, how they feel it to the biodiversity, or how they feel it to the soil, or how do they feel it to the kind different of plants. We need also not only just talk to the professors, we also talk to the agriculture engineers, or talking for another people who train in the farm, or talking to the farmer, or talking to the other growers, and so on. So to get experience from all these people around them is really important, to interact and to get knowledge from them. As I said before, it's hands-on experience, and also to gain knowledge from everyone is really closer to the environment. It was really important to increase their knowledge and increase their interactions with the environment. Next, please. This is more interaction. As you can see them like in the nursery, you can see them in the field, they are planting themselves. The number 4 picture is they are in the kitchen. And the fine thing, or the nice thing also, one of the activities is community-based learning. This is mean they have also some activity to interact with the community. The students, most of them come from urban region or come from city or something like that. So to make them also interact with the fields and to interact with the farmers or the simple community, or to make like a work like a prepare a meal for students in the school or students in kindergarten. It was really make them feel how much they are important to the community and how much they can participate to make this activity is really important, and how to feed them. This is kind of interaction we are looking for. Next. This is what I mean by the first picture. As you can see, this was my classroom. Okay. Now I leave the classroom, I leave the RC, I leave the chairs, I leave all the good facility to make me relax. But here I make them how to be closer to the environment, how to be closer to the earth, how to be closer to the sun, to the sky, to the temperature, and so on. So to see the trees is like this is their wall instead of the normal wall or concrete wall. Now you can see the trees. This is our world, and how to interact with every single organism they are around them. Next, please. So also one of this, in this agroecology, as you can see, we also interact with the plant disease, with the pests, with the insects, what kind of damage happen. And also to the end of their projects, we ask them to design their own farm. Like, what's your dream? As you can see in the first picture. So I make him do like a project in the end. talk about your own farm, your dream farm. So what you want to have it, what you want to implement it, what the things you want to have it, and what kind of crops you want to cultivate it. So how you can conserve the biodiversity in your environment. All this process is really important to put his in mind and really to design his final projects in the end of the 15 days after a long time of training in the farm. Next. So also we cannot forget the biodynamic preparation. So in HU, we move from the conventional agriculture to organic and biodynamic agriculture. So also the students introduced to the biodynamic preparations, how much they are really important and how much they are really good for the environment, and also all that process. Next, please. So this is what I'm talking about. Like, this is kind of final projects. They have it and they have to discuss their idea and express about themselves. So we also here focus about like the presentation skills, research skills, writing skills, how to write report, how to make a presentation. Like if you are in the farm, for example, so you don't need for a PowerPoint, you didn't need for computers, but you need here just how to present your idea and how to express yourself very well. Be sure also the art students have to be happy, give them like a good memories, okay? You also have to keep the disciplines, because this does not mean you are in the farm, so didn't come to your time, you come late. No, this is not allowed. So you have to teach them the disciplines, you have to teach them how to be on time, and also to give them like a good memories and happy time, and also to work in a group. In the beginning, all the students, they doesn't know themselves, they doesn't know other colleagues, but like after 15 days, they introduce themselves and become more closer. They eat together, they work together, they interact together. So they develop their own team in the end of the module. Next. So all the goals of the biodynamic, as I told it, it's a holistic approach. As you can see now, it's not just only me in plant protection. No, plant protection with the soil health, with a biodynamic preparation, with a cosmic calendar, and with IBM strategy, integrated pest management. All this kind of science work together to make a one unique module. They teach the students, they learn the students how to deal with all that kind of perspectives. So holistic approach here, I mean, all kind of different science, they are working together, plant protection, microbiology, and so on. So we make the students really understand like the whole picture of the farm. And you can see in the first picture, as you can see, the projects and how they can express about themselves in the end. The second picture, it was really nice picture because we were closer to the Women's Day. So as you can see, we also try to make them think about the International Day, like the women, how to be really more self-confidence and how they express about themselves and how to be strong in the farm, because this is not only a man work, it could be also like a woman work. Next. This is more practical learning experience we try to give them and how to interact with them. I love the second pictures because here the students likely implement like more traps, like sticky traps, yellow sticky trap, blue sticky traps, and so on for plant protection, and how to make all this climate change resilience and how to interact with the other pests, how to control them and how to monitor them. So we make them really closer even to the hazards or even to the invasive species that they could be found in the farm. Next. So when we make the questionnaire, like you can see in that table, so if you can see the competences here, like number one, observation, for example, we started by number 3. This is only 3. But after end of the training, it increased to 5, which was really a good increasing. Like after 15 days of working or after 15 days of the training, you can see it's increased to 2. Like it's really good thing. And the thing that I like it as well, we increase it so much, the reflection and dialoguing. So the reflection here, this is mean he can express about himself and he really show you how he much interact with the module. Dialoguing, now there's no barrier between the learners and between the facilitators, no barrier between the student and the professors. We can talk, we can express our idea, and also we can integrate together to make a good project in the end. Next. You can see here now in a different way in this chart how we can, the difference between the start, which is in the blue, and how it's increased in the end of the training. I think dialoguing was the best one, and reflection as well, because it's really increased so much compared to the beginning of the training, compared to the module in the end. Next. So everything was right, everything was perfect, everything was really great, but we have to mention our challenges. It was not that easy. The point is, like, we have a lot of challenges, like logistics, okay? So where the students going to stay, how much it will cost, the transportation. And one of the major things with challenges we faced in 2022, as you know, and 2021 as well, it was the COVID-19. So the pandemic prevent a lot of activities happen in this time, and we didn't continue in the way that we want, or to be continuous in the way that we want. So there was a challenges we got, and also the changing of HU stuff, like people they join us and people they disappear and people come again. All this kind of challenges we got in the previous years. So we tried to overcome them as much as we could, especially in the logistics, and try to make more people interact with us. So to know how much this module is important. And also we use our graduates. We have them now, our like facilitators with us, to give to the new students how much this module is really important. Now, I think the team is increasing gradually in a good way, with people they understand the idea and also people believe in the idea, to make them really interact together. Next. Next. So as I can see now, after a long time of progressing and after like 4 years of preparing of the biodynamic, now we can have to overcome all these things now, and we really, even our as a facilitator or professors, know how much is really important to change the syllabus from just to being giving all the time, no, to interact and make them interact with us, and really to give them the knowledge in a different way, or to give them all what we are knowing in a really different way, and to interact, and also to increase their satisfaction about the openness to the students and the teachers as well. Okay, next please. Thank you so much for the lovely invitation, and I really muchas gracias for everybody for the listening, and I wish to be more interact with you, and thank you for the Mexican team and the Hungarian team. I appreciate it.
Well, okay. No, thank you for your interesting talk, Reham, Professor Reham. We, as you know, we will leave the questions for the end. And now we have the next talk is Professor Patricia Manzano. Patricia Manzano Fisher. She is a postdoc student at the National University in Mexico. Now I'm going to translate and to speak in Spanish. Patricia es bióloga de la UNAM, con una maestría en ciencias por la Universidad de Oxford, y tiene un doctorado en ciencias de la sostenibilidad por la UNAM. Actualmente, Pati es investigadora postdoctoral en el Instituto de Geografía de esta misma casa de estudios. Es miembro prestigioso del seminario de Cambridge Global Food Security y del seminario permanente del Instituto de Geografía, donde ella está haciendo su postdoc. Su tema de investigación es acerca de la alimentación sostenible, y se centra también en las propuestas de dietas sostenibles y la forma en que puede diseñar intervenciones para poder cambiar conductas hacia sistemas alimentarios sostenibles en instituciones de educación superior. La trayectoria de la doctora Manzano integra la educación ambiental, la conservación y el consumo sostenible. Doctora Patti, por favor, empezamos, ¿sí? Está lista ya, ¿verdad? Are you ready? Sí. Ok. Gracias.
No se escucha, tiene el micrófono apagado.
¿Ya me escucha? Hola, hola.
Sí, ya te escuchamos.
¿Ya? ¿Y ven mi presentación?
Sí, 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 la vemos.
¿Ya la ven?
Gracias.
Muy bien. Bueno, pues buenas tardes a todos. Muchas gracias por la invitación para participar en este coloquio de agroecología, cambio climático y educación ambiental. Me da mucho gusto estar aquí con ustedes. Y el tema del que les voy a hablar hoy es ¿por qué la educación ambiental no basta? Estrategias integrales para una transición agroecológica. Y quiero empezar por contarles un poco de por qué estoy aquí y por qué hablo de educación ambiental y por qué no es suficiente. Durante más de 20 años me dediqué a hacer educación ambiental tanto en escuelas desde preescolar hasta preparatorias, di cursos para maestros, elaboré guías, di cursos de observación de aves, hice materiales para diferentes especies en peligro, hice muchísimo trabajo de educación ambiental. Y yo decía, pero si ya estoy haciendo todo esto, ¿por qué las cosas no cambian? ¿No? ¿Qué es lo que está pasando que no se ve ese cambio? ¿No? Eh, Más adelante yo di clases a nivel universitario, yo les decía, a ver chicos, ¿qué pasó? Cuando yo hacía educación ambiental en primarias, en chicos como ustedes, se supone que ustedes iban a resolver muchas cosas y pues todavía no vemos esos cambios, ¿no? Y pues sí, resulta que la educación no es suficiente. Entonces, en 2016 me metí a hacer mi doctorado en ciencias de la sostenibilidad y mi tema fue precisamente el ver cómo podíamos usar herramientas de psicología para cambiar la conducta de las personas. ¿Cómo podíamos hacer que esa información diera el siguiente paso hacia la acción? La educación ambiental es un proceso de aprendizaje que busca crear conciencia, dar conocimientos, que la gente cambie las actitudes y que comprenda y valore el medio ambiente. Esto con el fin de participar de una forma responsable en la solución de los problemas ambientales y de promover un desarrollo sostenible. Y durante mucho tiempo la educación ambiental se consideró la solución principal a los problemas ambientales, basándose en la idea de que el desconocimiento era el obstáculo central y que al informar a las personas, estas cambiarían sus conductas. Además, se valoraba como una herramienta para formar valores, para prevenir daños y para promover el desarrollo sostenible. Sin embargo, se ha reconocido que la educación por sí sola no es suficiente para generar cambios duraderos. Hay varias limitaciones claves que enfrenta la educación ambiental. El primero es un enfoque en el cambio individual frente a un cambio sistémico. Gran parte de la educación ambiental hace hincapié en acciones personales como el reciclaje, lo cual es insuficiente porque los mayores impactos ambientales suelen provenir de prácticas industriales y gubernamentales. Esto puede distraer la atención de abordar las causas fundamentales de la destrucción del medio ambiente. La segunda es esa brecha entre el conocimiento y la acción. Aprender sobre los problemas ambientales no conduce automáticamente a un cambio de comportamiento. Otros factores como las normas sociales, los recursos disponibles, el control de cada individuo, desempeñan un papel importante en las acciones de una persona. La educación ambiental aislada rara vez logra transformar comportamientos, porque el conocimiento debe complementarse con condiciones estructurales. Y hay factores como la falta de infraestructura adecuada, las normas sociales vigentes, barreras económicas, la desmotivación y sistemas que favorecen prácticas insostenibles que limitan la efectividad de esta educación. La educación choca contra un sistema que no está diseñado para apoyar las conductas sostenibles que predica. Hay tres tipos de barreras estructurales que impiden que la educación sea efectiva por sí sola. La primera son las barreras físicas y económicas. Esto es como la falta de infraestructura, que no haya acceso a semillas nativas, que los sistemas de riego sean ineficientes o no haya sistemas de riego eficientes, mercados donde se puedan vender los productos agrícolas o costos iniciales que sean muy altos. Las barreras normativas y de gobernanza, como las políticas, los subsidios y las leyes que van a favorecer un modelo agroindustrial convencional. Y normas sociales que presionan para mantener ese status quo, ¿no? El que no se cambie. Y las barreras psicosociales, que son la desmotivación, la fatiga ecológica, la comodidad de lo conocido o la falta de incentivos inmediatos. Aquí les presento 3 casos en donde se estuvo usando la educación ambiental. El primero es la deforestación en la Amazonía. Durante décadas se implementaron programas de educación ambiental en comunidades y escuelas, pero la expansión agropecuaria, la minería ilegal y la tala comercial superan los efectos que pueden tener esos programas de educación ambiental. Porque aún con conciencia ambiental, las necesidades económicas y la falta de alternativas productivas mantienen estas prácticas no sostenibles. Un segundo ejemplo es la contaminación por plásticos. Ha habido campañas globales que han promovido el reducir, reutilizar y reciclar, pero la producción de plásticos de un solo uso sigue en aumento por falta de regulaciones y la producción empresarial continua. La educación modifica las percepciones, pero no cambia estos sistemas de producción. Y el tercero es el manejo de residuos en México. Se han implementado programas de educación ambiental sobre separación de residuos, pero la mayoría de los municipios carecen de infraestructura para reciclaje o disposición final. Entonces, en este caso, la educación genera la intención, pero sin un apoyo institucional y económico, la práctica no se va a sostener. En la actualidad me he topado con muchas agencias internacionales que, reconociendo este problema, no están dando dinero para apoyar campañas educativas dentro de sus proyectos. En sus requerimientos ahora solicitan que sean intervenciones de cambio de conducta para apoyar los objetivos de estos proyectos. ¿Y qué son estas intervenciones de cambio de conducta? Bueno, pues primero vamos a ver qué es el proceso de cambio de comportamiento. En el proceso de cambio de comportamiento, lo primero que necesitamos es identificar cuál es el problema. Después, ¿qué conducta humana está involucrada en este problema? Ya que sabemos qué conducta, necesitamos saber qué debe cambiar y qué necesitan hacer las personas para cambiar. El siguiente paso es, ¿quién debe hacer este comportamiento? Y se tiene que ser muy específico, porque hay veces que son las personas, pero hay veces que son las instituciones, o que son cambios mucho más grandes que involucran a una sociedad, ¿no? ¿Y qué barreras hay para que la gente haga este comportamiento? Las intervenciones de conducta, las intervenciones de cambio de comportamiento son un conjunto de actividades coordinadas que están diseñadas para cambiar comportamientos específicos. Modificar el consumo de alimentos va a tener como resultado dietas con menos impacto. Cambiar los hábitos alimenticios, por ejemplo, es uno de los principales retos que tenemos para alcanzar una sostenibilidad alimentaria. Entonces, tenemos que ver cuáles son las barreras que hay para poder hacer estos cambios. Entonces, lo primero que necesitamos es información. Aquí quiero introducir el modelo Combi que propuso Michi et al. En 2014. Este es una guía práctica para diseñar intervenciones en diversos campos, no solo en campos de salud pública o comunitaria o política. Se puede usar en básicamente cualquier problema ambiental que podamos tener. El modelo Combi es una herramienta fundamental para entender por qué las personas se comportan de cierta manera y cómo facilitar que cambien estas conductas. Se centra en la capacidad, la oportunidad y la motivación que se tiene para hacer un comportamiento. Y el cambio de ese comportamiento va a involucrar que uno o más de estos elementos se modifiquen para cambiar el sistema. Mechi elaboró un libro que se llama La rueda del cambio de comportamiento. Es un marco integrado desarrollado por esta mujer y sus colaboradores para diseñar intervenciones de cambio de comportamiento. Ella organiza esta rueda del cambio de comportamiento en 19 intervenciones basadas en la capacidad, la oportunidad y la motivación, que es el centro verde que ustedes ven. Ese es el modelo Combi, donde está la capacidad, la oportunidad y la motivación. Este modelo ayuda a planificar intervenciones de forma sistemática al vincular las funciones de intervenciones, como pueden ser precisamente la educación, la persuasión o incentivos, que incentivos pueden ser positivos o negativos. Y esto con los factores del modelo. La rueda del comportamiento tiene en el centro del modelo Combi con 9 intervenciones. Ustedes pueden ver que viene ahí formación, persuasión, incentivos, medidas coercitivas, capacitación, el posibilitar los cambios, los modelos de conducta, la reorganización medioambiental y las limitaciones. Y tiene 7 categorías políticas que apoyan la entrega de esas intervenciones, como puede ser el medio ambiente y la organización social, comunicación y publicidad, legislación, prestaciones sociales, normas, medidas fiscales o guías. Estas intervenciones de conducta nos ayudan a, junto con condiciones materiales y transformaciones en las regulaciones, a cambiar un sistema. Y esto nos podría ayudar a una transición, hacia una transición agroecológica. Y aquí vemos que la educación puede fortalecer las competencias de los actores para facilitar estos procesos. Otra cosa que quiero introducir ahorita es la teoría de las instalaciones de Sadai Lahu. Y él habla sobre cómo el comportamiento humano está regulado por los entornos sociales y materiales, a los que él llama instalaciones. Este marco teórico explica cómo la mente, el entorno y las estructuras sociales interactúan para modelar la conducta de las personas, ofreciendo una perspectiva práctica para analizar y modificar el comportamiento humano. Entonces, aquí tenemos estas 3 entornos: el entorno físico, en el que es la parte material que nos rodea y los objetos que usamos. Y esta capa permite, facilita o impide ciertos comportamientos. Lo que hace es proveer capacidades para actuar. Luego tenemos el entorno institucional social, que pueden ser normas, reglas, valores, cultura, las redes sociales e institucionales que nos rodean. En esta capa se define lo que es aceptable, deseable o esperado de un grupo y establece lo que es legítimo y lo que se espera de las personas. Y el tercero es la conducta, que son los procesos mentales individuales, donde tenemos los conocimientos, las habilidades, los hábitos, las emociones, las metas y las percepciones. Y lo que proporciona son las competencias y las motivaciones para actuar. Aquí tenemos un ejemplo de estos entornos. Los 3 entornos van a guiar el comportamiento cotidiano de las personas de una forma estandarizada. Y podemos pensarlo como en el caso de un mercado, en donde la parte física va a ser la estructura del mercado, las calles que llegan a él, las diferentes entradas al mercado o la disposición de los puestos. La parte institucional van a ser las leyes que rigen el mercado, las reglas para vender, las normas que siguen los locatarios, las normas que siguen las personas, como podría ser el esperar su turno o el no mayugar la mercancía, y las expectativas sociales. Y el último es la conducta, que pueden ser las preferencias y los hábitos que tienen los clientes cuando acuden al mercado: qué es lo que les gusta comprar, dónde les gusta comprar, cuándo, cómo les gusta que esté, por ejemplo, la fruta que compran, ¿no? Estos son los 3 entornos en los que se van a dar estas conductas. La idea aquí es usar estos 3 entornos cuando estamos planeando una intervención para resolver un problema. ¿Y cuáles son los beneficios de tener un enfoque que integre estos aspectos? Y que la educación esté integrada dentro de este enfoque. El primero es que va a potenciar el impacto que tenga la educación, ya que el conocimiento se va a aplicar y se va a reforzar. Vamos a tener una facilidad para adoptar nuevas conductas, ¿no? Porque va a reducir las fricciones y los costos, tanto económicos como sociales, que produce un cambio. Luego tenemos que promueve cambios sistémicos a nivel sistema. No solo es pedirle a la gente que cambie, sino que el sistema cambie para que también las personas puedan cambiar y que esto sea duradero. Va a atacar los problemas desde la raíz y no solo desde los síntomas. Un problema, por ejemplo, puede ser los plásticos de un solo uso, ¿no? La gente ya había, los gobiernos ya habían puesto en México, por ejemplo, una legislación que prohibía los plásticos de un solo uso, ¿no? Entonces ya poco a poco estábamos realizando ese cambio, llega la pandemia y entonces todo tenía que ser sellado y protegido contra el virus. Y entonces todo ese esfuerzo legislativo y de las personas se nos vino abajo por un evento como fue la pandemia. Y ha costado mucho trabajo el volver a reencaminar tanto la ley como a la gente para que siga evitando el uso de plásticos de un solo uso, ¿no? También va a fortalecer la legitimidad y la justicia social porque la gente va a ver que un cambio es posible y se va a sentir apoyada, ¿no? Durante el tiempo, cuando se puso la ley para prohibir los plásticos de un solo uso, yo iba al mercado y llevaba mis bolsas de tela y la gente me decía, qué bueno que usted hace eso. La ley nos está pidiendo un cambio, pero necesitamos que los consumidores también nos apoyen, ¿no? Entonces, tiene que ser algo integral, que todos estemos en el mismo barco. Aquí les presento una tabla con casos donde se ha integrado la educación, el cambio de conducta, las normas y la infraestructura. Son de diferentes países de Latinoamérica donde se hicieron donde se hicieron proyectos de manera integrada y se trabajaron estos tres entornos, ¿no? El primer ejemplo es el de Brasil con una agricultura de bajo carbono. Ahí aplicaron capacitación masiva en siembra directa, rotación y recuperación de suelos, más políticas nacionales con incentivos crediticios y asistencia técnica y cambios en la infraestructura, que era maquinaria adaptada a labranza mínima y a manejo de cobertura, y el resultado fue una reducción de emisiones y una mejora en la productividad. Otro caso fue el de México con el café sustentable en Chiapas, donde se dio formación en agroforestería y certificaciones ambientales, apoyados por una norma de certificación que una organización llamada Rainforest Alliance estuvo aplicando, y una infraestructura hídrica y con secadores solares. Y esto ayudó a que hubiera una menor erosión y una reducción de los agroquímicos que se usaban en las siembras. Y el siguiente caso es de Colombia, en donde se trabajó en cuencas cafetaleras sostenibles. Aquí hubo educación rural sobre conservación de suelos y agua, más normas de buenas prácticas agrícolas y créditos verdes, y terrazas, drenajes, plantas de tratamiento de aguas mieles, y esto resultó en una menor contaminación y erosión. En Perú hay un caso, el de irrigación sostenible en Ica, donde se dio a la gente capacitación en gestión hídrica y gobernanza, más normas de gestión integrada de recursos hídricos y riego presurizado con reservorios y canales tecnificados. Igual tenemos una integración de los tres entornos que resultó en un uso eficiente de agua y una reducción de los conflictos. Otro caso es el de Chile, en donde para hacer una transición a agricultura orgánica se establecieron escuelas de campo y asesoría técnica en producción orgánica con reglamentos nacionales de agricultura orgánica y biofábricas que proporcionaban los insumos a los agricultores, más sistemas de compostaje, y esto resultó en una reducción de agroquímicos y un aumento en la rentabilidad de los agricultores. En Argentina se trabajaron suelos pampeanos sostenibles. Este proyecto hizo escuelas de campo sobre siembra directa y rotación, más una ley que hubo sobre conservación de suelos y programas provinciales, y un uso de maquinaria especializada para labranza mínima. El resultado igual fue un incremento de materia orgánica y una menor erosión. Y finalmente, el caso de la ganadería de bajas emisiones en Costa Rica, donde se dieron capacitaciones en pasturas mejoradas y manejo de estiércol con un programa del gobierno, un programa nacional de ganadería sostenible y la infraestructura de biodigestoras y sistemas pastoriles. Esto resultó igual en una reducción del metano y un aumento de la productividad de los ganaderos. Para sumar lo que estamos haciendo, ¿no? La educación es muy importante, pero se necesita articular dentro de los proyectos. Hay que definir cuáles son los públicos meta que vamos a trabajar en las intervenciones. Hay que identificar las necesidades de educación, información y comunicación que tiene el programa. Hay que definir conductas que se requiere cambiar y hay que desarrollar campañas educativas que apoyen las intervenciones que se van a implementar. La educación ambiental debe formar parte de estas intervenciones integrales que consideren las normas, la infraestructura, el conocimiento y la conducta, lo que va a potencializar su impacto, va a facilitar la adopción de prácticas sostenibles, va a promover cambios que sean duraderos y va a atender las barreras reales y a fortalecer la legitimidad social. De esta manera, la educación no solamente va a ser información, sino que va a ayudar a transformar conductas en entornos que son propicios para que sea sostenible. Se debe promover el trabajo interdisciplinario. Enfrentamos una crisis ambiental que requiere un trabajo colaborativo eficaz y orientado a soluciones. Necesitamos promover el trabajo entre investigadores en los campos de políticas públicas, investigadores sociales, antropólogos, psicólogos, conservacionistas, agrónomos, que puedan trabajar los proyectos de una manera integral y donde se tenga en consideración estos entornos físico, de normas y leyes y de conducta, para que se puedan alcanzar las metas de los proyectos. Y los proyectos deben estar, las metas de los proyectos deben estar diseñadas desde estas diversas necesidades entre todos, de manera que se complementen y que logren transformar estos sistemas que están causando tanto daño en nuestro ambiente. Y por mi parte, esto ha sido todo. Muchas gracias.
Muchas gracias, doctora Patti Manzano. Muy interesante tu plática de cómo fortalecer, ¿no?, las estrategias para contribuir en una educación ciudadana. Bueno, ahora, now we have the last speaker. Is an undergraduate student with her interesting project and innovative work that is in advance. Her name is Natalia Hernández González. Natalia Hernández González es una estudiante de la licenciatura de Biología de la UNAM. Forma parte de nuestro Laboratorio de Estudios Sociales de la Ciencia y la Tecnología y su investigación se enfoca en la evolución y domesticación de plantas en Mesoamérica. Su trabajo consiste en explorar cómo fue la trayectoria de comercialización del plátano, desde la domesticación hasta su integración en los sistemas agrícolas urbanos modernos, el cual refleja las dinámicas de intercambio biológico, transformación cultural y reorganización social. Su interés busca seguir mostrando las complejas relaciones entre naturaleza, ciencia y sociedad, y para contribuir en una mejor comprensión integral de la agricultura y de nuestra interdependencia con las plantas. Bienvenida, Natalia. Es todo tuyo.
Muchas gracias. Primero me gustaría, antes de empezar, agradecerle al Laboratorio de Ciencias Sociales de la Ciencia y la Tecnología, específicamente a mi asesora de tesis, a la doctora Torrens, y también al doctor Arzu Rivera por invitarme a estar aquí compartiendo un poquito sobre mi trabajo con ustedes. Como ya comentó la maestra Alice, yo trabajo con el plátano, específicamente con el punto de vista historiográfico, en donde abordo temas económicos, sociales, históricos y culturales. Aquí les presento un poquito de la tabla de contenidos, para darnos una idea de lo que voy a estar presentando. Y para comenzar me gustaría presentarles el plátano y mi interés específicamente sobre él. Antes de todo, me gustaría decir que esta presentación tiene objetivo de ser un caso de estudio de lo que podría funcionar el punto de vista multidisciplinario en los cultivos y su estudio historiográfico. Para empezar, el plátano es uno de los cultivos más antiguos a nivel global. La revolución agrícola data de hace 12,000 años y hay como precedentes históricos en donde el plátano tiene antigüedad de hace 10,000 años, al menos su cultivo. Sin embargo, llegó a Latinoamérica y América en general durante la colonización, en donde se adaptó exitosamente. Posteriormente a este periodo de adaptación, comenzó a dispersarse por todo el continente, llegando a ser uno de los cultivos a nivel global más importantes. Actualmente ocupa el 7º lugar de importancia después del arroz, el trigo y el maíz en alimentos básicos en nuestra canasta de alimentación. Además, es considerado uno de los productos básicos en la economía de varios países. Está el concepto llamado repúblicas bananeras, que son estos países que en algún momento de la historia su economía se basó en la producción de plátanos. Y por último, me gustaría también presentarles las problemáticas que me ha llevado a hacer este estudio de caso, que es el panorama actual. Actualmente sufre una como pandemia de un hongo, el Fusarium oxysporum cubensis, que ha arrasado con cultivares a lo largo de su historia industrial y de cultivo. Entonces es importante como que tomar este punto de vista para analizarlo desde el ojo agroecológico. Primero, me gustaría también presentarles mis preguntas de investigación que me llevaron a desarrollar la presente investigación. La primera fue cómo ha sido resignificado el plátano dentro de las distintas culturas. Para poderme responder esta pregunta, ya que identifiqué mi investigación como algo historiográfico, me basé en el trabajo de Arjuna Padurai y de Donna Haraway, en donde presentan la identidad social de las cosas y la agencia de lo humano. Dentro de estos conceptos se aborda la dimensionalidad de los objetos. En mi caso, como bióloga, yo tomo el punto de vista pues, biológico del plátano, donde pues tiene no solamente una importancia económica, sino también la ha tenido histórica, social y culturalmente hablando, por lo que es importante abordarlo desde varios puntos de vista, permitiéndole tener una vida social, por así decirlo. Posteriormente, me pregunté cómo es que circuló el plátano desde su centro de origen en Asia hacia otras regiones del mundo, especialmente en México. Cuando comencé mi investigación, me enteré que el plátano no es originario de América, que era lo contrario a mi percepción del fruto. Al contrario, viene de un archipiélago mucho más lejos, que está en Papua Nueva Guinea. Entonces, una de las preguntas como bióloga me dice, pues, ¿cuáles son sus procesos de diversificación? Ya que no tiene o tiene reducción de semillas, ¿no? Para poder responder esto desde un punto de vista un poquito más dimensional, tomé el punto de vista de Kapil Raj y de David Livingstone, en donde ambos autores abordan la circulación del conocimiento y de los procesos históricos. Hablando un poquito más en términos historiográficos, para saber la historiografía de un estudio de caso es importante identificar quiénes son los intermediarios, cuáles fueron las redes de conocimientos que se fueron tejiendo y en dónde se comenzaron a tejer. Particularmente Livingstone nos menciona sobre cuáles son los lugares en donde se hace la ciencia. Contrario a lo que se piensa, la ciencia no se hace dentro de un laboratorio, sino se puede hacer en cualquier lugar, en espacio que se permita, al igual que la circulación del conocimiento, que a lo largo de esta historia que les voy a ir relatando, se va a ver cuáles son los nudos que se fueron tejiendo. Y por último, ya que este es un estudio de caso, quise basarme en otro estudio de caso, como el de Sidney Mintz, que ocupa el azúcar o la caña de azúcar, para hablar de justamente este mismo proceso de globalización de un cultivo. A diferencia que ella identifica las estructuras de poder que vamos a ver que es, por lo regular son la política, la academia y la economía. Estas tres estructuras se van a ir como viendo presentes dentro de la historia, siempre juntas, nunca separadas o alguna con protagonismo más que la otra, pero siempre trabajan en conjunto, lo cual es importante para identificar cómo es que se fue estructurando y cuál fue la importancia detrás de globalizar este cultivo. Pues bueno, para ahora sí comenzar a hablar de la historiografía del plátano, primero me gustaría presentárselos como el ojo biológico que tenemos del plátano. El plátano pertenece a la familia Musaceae y esta a su vez forma parte del género Musa. El género Musa comprende muchas especies y variedades, por lo que se divide en secciones. Las secciones son como estos apartados para concatenar las variedades y especies que se van generando a lo largo de su variación de genoma, ¿no? Estas se dividen conforme al número de cromosomas. En la sección Musa encontramos las especies y variedades que tienen 22 cromosomas, mientras que en la sección Calimusa únicamente las que tienen 20 cromosomas. Dentro de la sección Musa encontramos los cultivares domesticados, que son los importantes para relatar esta historia. Principalmente está Musa cuminati y Musa balbiciana, que son como los que dieron paso a las demás variedades endebles que nosotros conocemos en el occidente. Mientras que en Calimusa se encuentran los plátanos fei, que son plátanos por lo regularmente conocidos en el oriente, ya que son como característicos de su cultura. Estos, a diferencia de los plátanos de la sección Musa, crecen de forma erecta hacia arriba y tienen como tonalidades un poquito rojizas, moradas, naranjosas, además de que también alberga algunas especies y variedades de importancia ornamental. Como les comentaba en un principio, su centro de origen se encuentra en Papua Nueva Guinea, que es esta pequeña isla a un lado de Indonesia. Aquí las teorías más acertadas mencionan que se produjo una hibridación natural por parte de Musa balbiciana y Musa cuminata, lo que le confirió como la característica endeble que llamó la atención de los grupos asentados dentro de este archipiélago. A partir de que se llamó la atención, entró en un proceso de domesticación, que más o menos, para a grosso modo decirlo, es la selección y la eliminación de caracteres de interés. Uno de los caracteres de interés principales fue su forma de reproducción. El plátano tiene una forma de reproducción asexual en la que su rizoma va desarrollando un hijuelo que posteriormente, al cortarlo, puede ser una planta independiente a la planta madre, que esto es importante más adelante para nuestra historia, entonces, ojo ahí. Otro de los caracteres de interés fue la pérdida o reducción de semillas. Aquí les hice un pequeño GIF en donde se puede ver cuál fue como la modificación morfológica principal. En un inicio, aquí podemos ver que la cáscara tiene otras tonalidades, es un poquito más gruesa, el fruto o la pulpa es menos y se dice que tiene como menos suavidad a comparación de la que conocemos actualmente. Conforme comenzaron a seleccionar y eliminar estos caracteres, empezaron a seleccionar aquellos plátanos que presentaran menos semillas, más pulpa, una cáscara más fácil de pelar, por lo que comenzaron a cultivar estos y promover este tipo de estética, por así decirlo, hasta el plátano que tenemos hoy en día. Como les comentaba, la dispersión del plátano es una de mis preguntas de investigación y al responderla me llevé como bastante información importante para su historia y para el punto historiográfico. Este territorio comprendido entre Papua Nueva Guinea, Indonesia y el norte de Australia se identifica como austronesios. Los austronesios fueron los grupos humanos que se asentaron dentro de este territorio y se presume, según las teorías como más acertadas, que ellos fueron los culpables de la dispersión del plátano. Principalmente entraron hacia el continente africano por Madagascar, posteriormente se dispersaron por Tailandia, Malasia, hasta llegar a India, donde encontramos precedentes históricos muy importantes. Les presento uno de los templos mejor conservados y más antiguos, en donde ya podemos ver la imagen en sí del plátano. Aquí vemos que la imagen es un poquito más moderna, o la podemos identificar a lo que nosotros conocemos como el cultivo actual, ¿no? Entonces, este templo data de 3000 a.C., lo que nos podría dar como una idea de cuánto es su antigüedad y cuál es su importancia dentro de distintas culturas, ¿no? Aquí ya se comienza a entrelazar la vida social del plátano, comienza a tener una profundidad, no solamente estamos hablando de algo que comemos, sino como que algo está reflejado en la cultura. Para acelerar un poquito el proceso historiográfico, me gustaría saltar unos 16 siglos, en donde comienza el momento clave para su globalización. La colonización de la monarquía española es uno de los puntos clave, ya que dentro de sus territorios se encontraba Islas Canarias. Como les comenté anteriormente, gracias a los austronesios entró el fruto a África y se fue como diversificando e insertando de forma exitosa, llegando a las Islas Canarias. Cuando llega a las Islas Canarias, aquí es un hotspot para su producción y para su mercantilización. Aquí es donde cosechan el plátano, el algodón, olivos, caña, todo lo que necesitan para entrarle a todo esto de las frutas mercantiles y demás. Y pues bueno, ya no sabemos la historia de que le cierran la ruta por donde querían pasar, por lo que de pura casualidad encuentran en nuestro territorio el continente americano. Aquí es donde comienza nuestro primer, bueno, no, desde las Islas Canarias yo identificaría como primer nodo de relación de donde se comienza a circular el conocimiento. Posteriormente, al llegar al territorio americano, comienza esta circulación y se comparte el conocimiento de forma interesante para mi investigación. La pregunta del millón, ¿cómo es que se comenzó a insertar dentro de nuestra cultura? Como sabemos, el territorio mexicano y bueno, bastantes territorios dentro de Latinoamérica entraron en un proceso de colonización en donde no tenían como solamente una forma de colonizar de manera bélica, sino también ideológica y religiosa. Dentro de las como consignas de la monarquía había la reubicación de los pueblos indígenas, en donde se reubicaban a villas o, sí, pues villas que buscaban como civilizarlos, despojándolos de sus territorios y dejando atrás sus milpas. Esto es muy importante ya que dentro de estas villas siempre había un convento el cual contenía un huerto. Dentro de estos huertos se presume que era como espacios de aclimatación de los cultivos tropicales y además un espacio en donde se circulaba el conocimiento, pero de una forma un poquito superior e inferior. Las personas que quedaban dentro de las villas tenían solo una opción, o morían de hambre o entraban pues a todo este doblego de cultura y aceptaban la religión y por lo tanto la monarquía española. Una vez que aceptaban pues todo este proceso de colonización dentro de los huertos, comenzaba un proceso de trabajo obligatorio en donde aquí se les enseñaba cómo cosechar, de qué forma iban acomodados los cultivos y demás. En el Códice Florentino podemos ver que justamente aquí se comienza a ver la ideología del orden de Dios, ¿no? Por un lado están los cultivos, cada quien con sus especies, no como en la milpa, que todo está como en una sinergia constante, no. Aquí todo está de un lado y del otro y se separa por una cruz porque lo protege Dios. Entonces, esto se podrá decir que es el inicio del monocultivo, por así decirlo. Es la misma estructura que más adelante veremos cómo se intensificó y qué es lo que nos ha traído actualmente. Otro punto de circulación de conocimiento y relevante para la historiografía del plátano en Latinoamérica es la adaptación del cultivo dentro del territorio. Los precedentes históricos mencionan a don Vasco de Quiroga, un religioso muy importante dentro de la colonización española, que estaba a cargo del obispado de Pátzcuaro, Michoacán. Aquí se asentó, pues obviamente la población, como ya les comentaba, tenían política de reubicación. Entonces, don Vasco de Quiroga, al ver las etapas de hambruna que se estaban presentando, dado a que pues, ya estaban dejando sus milpas atrás y no tenían que cosechar ni que comer, pues él para un poquito hacer que se acepte y que se comience a adaptar la cultura nueva con la posterior, les dejó cosechar plátano. Hay cronistas de esta época que mencionan que don Vasco de Quiroga personalmente viajó a Veracruz para traer algunas plantas de plátano y así y se las dio a las personas que vivían y aceptaban su religión, por lo que rápidamente las comenzaron a adaptar y cosechar. Lo que dio resultado a nuestra vasta cultura ¿qué fue la palabra? De cocina. Dentro de México, el plátano es característico por muchos de los platillos, por ejemplo, los molotes de plátano en Oaxaca, la cochinita pibil, en donde se ocupa la cáscara de plátano, y también los plátanos con crema y queso de Veracruz, que son característicos ya de nuestra cultura. A su vez, también se fue como diversificando el fruto, teniendo nosotros nuestras variedades locales, como el plátano morado, que es característico en Día de Muertos, el plátano macho, que también lo ocupamos bastante, plátano bolsa en Puebla y demás. Ya eran variedades locales que se comenzaron a insertar y ser como sinérgicas dentro de nuestra cultura, llegándose a confundir el cultivo como originario de Latinoamérica en general. Bueno, voy a saltar un poquito de tiempo. Posteriormente a la independencia y a la colonización y la independencia, comenzó el proceso de modernización agraria, que es entre la revolución y un poquito después de ella. La modernización agraria tiene, pues sí, su origen en la revolución, ya que se comenzó a inyectar a la infraestructura al campo, porque una de las políticas de del porfiriato era la modernidad y la civilización de los pueblos indígenas y demás, también contando con el sector agrario. Aquí se buscaba que fuera rentable, necesario y limpio, por así decirlo. O sea, no querían como estos conocimientos tradicionales, querían nuevas tecnologías, por lo que se empezó a hacer la infraestructura de las vías de ferrocarriles, a ocupar mejores instrumentos de agricultura, ya que el hierro se estaba como comenzando a usar bastante, lo que a su vez dejó descontento por parte de los que trabajaban en el mismo campo. Está la frase de la tierra es de quien la trabaja. Pues sí, justo, se empezó a menospreciar todos estos conocimientos y empezaron como a hacer una superioridad en cuanto a lo que se necesitaba para entrar al ruedo capitalista. A partir de 1900 hasta la fecha se comenzó a hacer la intensificación de los cultivos, dejando como que al campo un poquito no suficiente para el nivel de producción que se estaba necesitando en esa época. Además de que posteriormente a la colonización, las tierras que pertenecían a la iglesia se vendieron al mejor postor, dando entrada a la inversión extranjera. Y aquí será otro punto relevante, un punto de circulación, de conocimiento también y de historia dentro de la historia del plátano. Al entrar la inversión extranjera, no tanto en México, pero al menos sí en la parte de la región platanera, como les comentaba, bananera, entró pues la Unit Fruit Company, que es una de las compañías más relevantes en cuanto a la producción de plátano. Aquí se comienza a ver la estructuración del poder muy fuerte, ya que para Estados Unidos esta era una de sus inversiones más importantes, por lo que no solamente estábamos hablando de economía, ya se veía entrelazado la política y la academia. Más adelante veremos por qué. A la Unit Fruit Company se le comenzó a apodar el pulpo, porque tenía sus manos metidas en todos lados. Entonces, como les decía, no únicamente era como un interés económico, sino ya también político, llegando a ser como una forma de dominio tan fuerte que incluso en los presentes históricos tenemos un poquito de esta etapa de la platanera en 100 años de soledad. Quien ha tenido el gusto de leerlo sabe que se menciona un poquito sobre la matanza de la platanera, que fue un hecho en 1928 en Colombia, donde los grupos de trabajadores inconformes con las prácticas y jornadas que se llevaban dentro de la platanera se manifestaron, pero la Unit Fruit Company financió a las Autodefensas Unidas de Colombia para silenciarlos, no solamente en 1928, sino también en 2007 y posteriormente en 2017. Hoy en día, la Unit Fruit Company, actualmente Chiquita Brands International, lleva una condena económica de $38,000 a familiares de víctimas, pero pues solo es un poquito de la pincelada de la historia que fue con la interacción de la economía extranjera y las regiones latinoamericanas. Para explicar un poquito más de cómo fue su éxito dentro del mercado, me gustaría hablar de la estandarización del mercado, que es importante para entender el por qué estamos en esta crisis fitosanitaria. Para empezar a vender, al darse cuenta que el plátano tenía bastantes variedades en tamaños, colores y sabores, lo que hicieron fue buscar un cultivo que fuera estándar, homogéneo y de cierta forma bueno para todos, o sea, que el paladar de todos quedara dentro de este cultivo. Han scrolleado por Facebook, ven como que la noticia de el sabor de chicle que tus abuelos probaron, pero tú jamás vas a poder, de plátano, que tú jamás vas a poder probar. ¿Por qué? Porque el plátano Gros Michael fue líder en el mercado desde 1900 hasta 1960. Sin embargo, durante estos 60 años, estuvo batallando con el hongo Fusarium oxysporum cubensis, raza 1, el cual tiene un mecanismo de ataque bastante agresivo. Se puede alojar en la tierra durante años sin necesidad de un hospedero, pero cuando encuentra un hospedero comienza a entrar por las raíces, bloqueando los canales de obtención de nutrientes, haciendo que la planta se seque de adentro hacia afuera. Este plátano es súper resistente a agroquímicos, a la quema, a todo lo que intentaron dentro de la agroindustria, no lo lograron. Entonces, por ahí de 1928, 1930, se dieron cuenta que esto ya no iba a ser rentable a futuro, por lo que financiaron al College of Tropical Agriculture para hacer expediciones a Papua Nueva Guinea y poder buscar una variedad de plátano que sea resistente a esta y a otras enfermedades que atacaba al cultivo de plátano. Así es como llegamos con el plátano tipo Cavendish, que son los plátanos que actualmente nosotros hoy consumimos. A diferencia, no tiene tantas diferencias en cuanto a sabor del plátano Gros Michael, pero sí morfológicas que se fueron adaptando, ya que también tuvo que estructurarse una nueva forma de viajar con el fruto. Se empezaron a implementar la interdisciplinaridad entre ingeniería, entre biociencias y demás, ¿no? Entonces aquí es como que empieza la circulación y a crearse conocimiento en torno al plátano. Además de que aquí otra vez se viene presentando la academia, la política y la economía juntas trabajando. La Unit Fruit Company comenzó a financiar instituciones académicas para poder como sustentar a la larga su minita de oro. La Fundación Hondureña de Investigación Agrícola dentro de Latinoamérica es líder dentro de la mejoramiento de variedades de plátano tipo Cavendish. Esto con el objetivo de que si vuelve a arrasar este hongo que lo está haciendo o alguna otra enfermedad que ya no esté en el control de la agroindustria, automáticamente se pueda reemplazar, como lo hicieron con Gros Michael, con otra variedad de importancia económica. Además de que el INIVAP es un centro que se dedica a hacer una red de circulación de conocimientos en torno al plátano, para mejorarlo, para buscar como estudios en cuanto a su fitomejoramiento y demás, ¿no? O sea, todo esto con el fin de también no perder el punto de vista, que es seguir alimentando a la agroindustria. Y su como trabajo más relevante es el banco de germoplasma más grande de plátano, en donde se albergan variedades que puedan ser resistentes al hongo que les mencionaba y a otras enfermedades. Desafortunadamente, no siempre se albergan variedades de importancia biocultural nativas o, o de otro índole como local. Esto es gracias a la agroindustria. La agroindustria tiene como que este esquema de trabajo en donde se produce principalmente todo en monocultivos, dependencia de una sola variedad, y gracias a Norman Borlaug, que es el como principal intermediario de la Revolución Verde, quien propuso este esquema de cultivo y el uso de agroquímicos, es que hoy en día la agroindustria ha tenido como que bastante como tambaleado en cuanto a mantenerse, ya que al tener una sola dependencia y baja variedad de genética, estos frutos ya no tienen como resistencia a las enfermedades que les atacan, generando descontento dentro de la academia, recordando que la academia no es como un solo pensamiento en sí, hay varias corrientes. Desde 1920 se viene como promoviendo este nuevo pensamiento, esta disciplina en construcción actualmente, que es la agroecología, en donde principalmente se habla de la protección de variedades locales y nativas, porque ese germoplasma de cierta forma tiene una importancia biocultural. Además de que también se promueve la protección del conocimiento local, tradicional, para tener lo que es el derecho a los alimentos limpios, suficientes y con una mejor propuesta de producción, para que así sea rentable para todos, porque dentro del campo ya no ha sido rentable la producción de todo de estos alimentos. Entonces es importante cuestionarse cuáles son las prácticas que necesitamos para que haya una sostenibilidad dentro de esto que es tan importante como la alimentación. Para irme encaminando un poquito a la conclusión, me gustaría presentarles una pequeña investigación que hice, que es sobre el posicionamiento de la agroecología actualmente. Ocupé la herramienta de Dimensions, en donde busqué palabras clave como agroecología de banana, en el caso de mi tema, y vi el nivel de publicaciones, o bueno, la cantidad de publicaciones de este año, dándome un, pues, dato bastante relevante, además de que con el concepto de agroecología busqué quiénes son los intermediarios que están produciendo este conocimiento, teniendo como principales líderes India, donde es uno de los centros de diversidad más grandes del plátano, posteriormente está Estados Unidos, después Argentina, Brasil y hasta abajo está México, nada más que ya no me salía en la tablita, pero se puede ver cómo es que se está retomando y agarrando fuerza dentro de estas herramientas y se está hablando de cosas, de temas importantes en cuanto a la agroecología. Aquí podemos ver las cifras de que va en popa a partir de 2019 hasta la fecha. No tenemos las cifras de este año, pero pues esperemos sean exitosas y más con este congreso, y coloquio, perdón. Y pues bueno, para finalizar, como les comentaba, este solo es un estudio de caso en donde podemos ver cómo es importante analizar los cultivos, no solamente desde nuestra trinchera, que será como bióloga, me competiría únicamente lo fitosanitario. No, también es importante la multidisciplinaridad, trabajar con la economía, con la cultura, con la historia, con todo amplio para poder tener un panorama y poder analizar mejor. Sabemos que actualmente el plátano también está teniendo estas inconvenientes con el mismo hongo, pero otra raza distinta. Entonces, ahora tenemos la oportunidad de posicionarnos desde el punto de vista agroecológico, ya que tenemos las herramientas y la posibilidad de hacerlo. Entonces, creo que se invita a todos a hablar y pensar de agroecología y no solamente desde la trinchera de uno. De mi parte es todo. Muchas gracias.
Muchas gracias a ti, Natalia. Te felicito. Well, I can only thank all of you for sharing with us some of the research projects on the challenges we face today in the face of this climate crisis. Now we have some questions that for all of you. I'm going to read some of the ones that they sent us at the YouTube. Many congratulations for Floran, for everyone. For Floran, Aferdita Shala say that your work is so great for her work in injury. And Irama Núñez say that for Floran, what is the perception of farmers in the region where you conduct your research on climate change? What might be their interpretation of these changes? This is one question, and I have another question from Floran, and later we can probably start hearing your answer, Floran.
Yeah, I would answer the first one. So,
do you want me to repeat it for you?
No, I found it on YouTube when I was following it.
Flora?
So well, the perception as the farmers, they are farmers, so it's for them they know as a concept that it's climate change.
We cannot hear you. ¿Sí? Ah, ok. Yo no lo oigo. Ok.
Is it working?
Ah, tengo que subirle.
Can you hear me?
Yes, please, you can go ahead.
Yes, go
Okay.
ahead, please,
Yeah.
Flora.
For as I was telling that the farmers they do know as a climate change as a concept, but they don't really know the effect that is going straight to them as a policy, or what is going to be the effect. So they know it as a news, but what I would like to mention is that once when I was doing the field monitoring of the canopy cover and the soil moisture, we went to visit a farmer that had issues with his irrigation system. And as agriculture, my supervisor, he had the opportunity to talk with him, and he was explaining that the farmer is asking from us if it's this time is suitable for irrigation, which for corn at the time it was already too late. It was already end of August, mid of August, something like 19 to 20 of August, if I remember correctly. And at the time, if you're irrigating the maize or the corn, whatever you can call it, is it's too late. So, and he was like furious that he was saying like, yeah, I just lost probably like 4 tons per hectare, at least by missing the irrigation timing. So yeah, in a way, a farmer does know what is climate change. He might not be able to explain to you, but he will tell you the effect of the weather that is happening on his region. So yeah, if this would answer the question, then I
The
think
question.
the farmer does know the effect, and
Okay.
they really
Then
need to learn the remediation or mediation techniques for that.
thank you, Florent. There is another question for you. Which is the potential of the apps like AquaCrop and the Earth Engine engine you mentioned of Google to prevent agricultural disaster like floods or plagues?
If I understand correctly, so the aquacrop is a model that it will model the growth history of the model of the vegetation period. So if we are modeling the previous years, we know in a way with and if we are using forecasting, we can forecast the coming year. For example, since I have the model for at least 3 years, I can forecast in a way the next year, but it's not accurate. So I can only forecast in a way with a model that was developed by University of or department, University of Mate. The idea was to forecast at least for 2 weeks in advance to tell the farmer, yeah, maybe in 2 weeks is going to be a drought, then you should irrigate at this time, so the plant will survive this drought period. But when it's coming to flooding, also flooding can be detected in the soil profile of the model, that it will tell you that you shouldn't irrigate because the crop will have issues with clotting of the roots with the air, but it doesn't really model the flooding, if I understand correctly the question.
Okay, thank you very much. For Professor Joseph Gembelim, somebody asked you, what actions like a soil doctor are the most important to mitigate the stress in the case of extreme weather floods or desertification? Exist any externalities that soil doctors could not see in the big picture?
Yeah, it's a good question. We always start an answer when it's hard to answer a question that it is a good question. I'm sure, and this is my belief, that every problems, agriculture-related problems, should be investigated in a certain agroecological regions. At the beginning of my presentation, I emphasized that the agroecological factors like soil and climatic factors together determine the agroecological potential of a region. So we have to find the most limiting factor. If it is the soil, like desertification due to the texture of the soil, or desertification due to the climate or the climate change, we have to check the interactions. In some places, irrigation is a solution, but it depends on of course, in the availability of water, the quality of water, because there was no time, so I didn't mention that we also have to face secondary salinization problems due to irrigation with saline waters, slightly, but saline waters. So irrigation, of course, if the soil is suitable, and of course the crops are suitable for irrigation, and where the water shortage is not huge, so desertification, for example, is an extreme. But then if we can mitigate the evaporation loss by different agricultural techniques, then that's the solution. And of course, if there are more limiting factors, we have to combine all these operations together. But first of all, we have to survey what are the limiting factors and what are the best solution specifically for that agroecological region.
Okay, thank you very much. Well, you have received a lot of regards from Latin America and from Venezuela. And Irama Núñez says, Dr. Riham, that your project is very inspiring. And I have a question for Professor, let me see, Professor Riham, I think it's Riham, let me see. Riham, there are scholarships for foreign students at your university,
Well, we don't have this kind of internship, but I mean, if someone he won't really show interest to join, for sure, yeah. And I'm not sure about the process or the budget, but maybe if he can come, maybe we can do like kind of discount for him, provide like accommodation if you want to get this training, and also like kind of meal with a good price for him. But to have a like internship or fellowship, we don't have this idea yet, because this kind of training is provided by the university to its students. So, but if someone from outside he want to join, for sure he's welcome. But actually, we don't have like a fund for him. That's the point is. So if the student want to join by his own fund, yes, we can. He's so most welcome, and we can help like provide like accommodation, food, and so on with a good prices for him to continue his stay.
Okay, thank you very much. Now we have a question for Patricia Manzano. Chantal Espinosa te pregunta y felicita por tu exposición y dice que si hay indicadores para evaluar los cambios de comportamiento proambientales en las actividades de educación. Esa es una de las preguntas y creo que tienes otra por acá. A ver, coordinador. Si los casos que presenta sobre capacitación e información se hicieron considerando algunas dinámicas didácticas y cuáles se aplicaron. Thank you. El micrófono está apagado. Gracias.
Perdón. Muchas gracias, Alicia. En el caso de lo que presenté, las capacitaciones que incluyeron dinámicas didácticas fueron, por ejemplo, en Brasil y en Argentina, que tenían las escuelas de campo y tenían parcelas demostrativas. En México tenían talleres prácticos y aprendizaje entre pares. En Perú y en Costa Rica había giras técnicas y trabajo con grupos locales. Y en Chile había una combinación entre clases teóricas con las prácticas en las biofábricas y con huertos demostrativos. Y para la pregunta sobre los indicadores, había indicadores directos e indirectos. Entre los directos era, por ejemplo, la adopción de las prácticas sostenibles, que puede ser el porcentaje de productores que aplicaban la siembra directa o que aplicaban rotación de cultivos, la reducción en el uso de los insumos químicos, de los agroquímicos, el uso de esa infraestructura ambiental, como por ejemplo el número de biodigestores o de terrazas o de composteras o de biofábricas que estaban en operación, o el mantenimiento de las coberturas vegetales y los suelos protegidos, que en el caso de Argentina. En la participación de los continua en los programas y entre las que en Brasil, por ejemplo, había un porcentaje de superficie con prácticas de bajas emisiones y reducción de fertilizantes, o el número de productores certificados en los cafetales en Chiapas, y la adopción de estos sistemas silvopastoriles y el uso de biodigestores en Costa Rica. Espero haberles contestado con eso.
Y
Gracias.
por último, Pati, la doctora Iramas te pregunta que la educación ambiental crítica va más allá del cambio de comportamientos para lograr las transformaciones necesarias en la actualidad. ¿Cuál es tu opinión al respecto?
Es decir, yo creo que tiene que ser un enfoque integrador. No puede trabajar los problemas que los proyectos tengan componentes profesionales que estén trabajando en cada uno de los entornos, porque si queremos solucionar el problema de ofrecer alternativas a los productores, va a ser muy difícil que eso ocurra, ¿no? Entonces, podemos decirle a la gente todo lo que queramos sobre no usar plásticos de un solo uso, pero mientras todos los productos que compren vengan en empaques, va a ser muy difícil que la gente lo deje de usar. Entonces, ahí necesitamos una legislación atrás y también necesitamos alternativas, porque el asunto es que necesitamos cambiar estos sistemas que no están funcionando. Entonces, la educación no es la solución, como tampoco la legislación o tampoco la infraestructura. Creo que tiene que ser un enfoque integrador.
Muchas gracias, Pati. Ahora para Natalia, pues ahí tiene varias felicitaciones por tu presentación, por tu desempeño como estudiante de undergraduate student. Entonces te pregunta Julián Rodríguez, ¿cuáles serían las perspectivas futuras para la recuperación de cultivos y diversidad biológica?
Muchas gracias, Alice, de verdad. Y considero que una de las perspectivas a futuro sería como justo seguirnos posicionando dentro de la producción de conocimiento de agroecología, además de que tengo entendido que en el Colegio de Estudios Científicos y Tecnológicos del Estado de Yucatán actualmente están promoviendo un banco de germoplasma de plátano, pero la pregunta sería, ¿qué tipo de germoplasma van a aceptar dentro de su banco? O sea, sería muy interesante ver la preservación de este germoplasma local y nativo, que es muy importante para seguir hablando a futuro sobre las mejorías del cultivo. Gracias.
Gracias, Natalia. Me parece que Arzu tiene una pregunta para la doctora, ¿verdad? Arzu, go ahead.
Reham, for Dr. Reham, I want to ask you if you have faced any barriers to develop agricultural education in a dominant global model of modern techno-agro-system that we face now. And I think Egypt is Mexico, of course, and Hungary is like big producers in food production. So I want to know which barriers do you face with your students, with the organizations or institutions when you are developing your work. Thank you.
Yeah, thank you so much, Arzu, for the question. Actually, it's really good question, but very broad, like talking about challenges. You've been to Egypt before here, and you see there's a lot of challenges, like maybe not all the stakeholders can also cooperate with the education sector. This is one of the things. And also like like financial issue. This is also one of the things we got there. If you want also to apply, for example, the agroecology system or the agroforestry approach, actually not all the farmers understand the idea how much it is important to implement this kind of process in their farm. Because the farmers, he really think about how to get money and how to increase his yield production and how to get like a very quick profit for himself. So using chemicals, as you know, is the most easiest and cheapest also way to reduce the hazards of the pest. So once you put the application or use the dose of the pesticide, so the pest will die immediately. So to raise the awareness and increase the awareness of the farmers to know how much the agroecology process and not using chemicals is important, it will take a long time. And this is the problem, I was in, like, from this last week, I was in Kafr el-Sheikh, is governorate here in Egypt. We tried to convince the farmers, around like 25 farmers, not to use chemicals. Okay, once they attend the session, they understand you very well and they believe that you are correct. But when we get to their farm, actually you can see all the huge containers from pesticide or a huge bottles they are throwing everywhere in the farm for the pesticides as well. So to increase the awareness of the farmer about the importance of not using chemical is really a huge challenge. One of the challenge also, you want to make the students believe in the importance of the health environment and the soil health. So this kind of education system and transform it from classroom to the field is really important, but actually also take a long time. As I told you, the module of the biodynamic training, it was started in 2018, but it takes a long time for more progress and more development to be like 6 modules now to serve each concept of this kind of agriculture process.
Okay, thank you very much. Well, this is the end, and Dr. Ana Barahona, coordinator of the SUHFECIM, and Dr. Arzu Rivera, coordinator of this Coloquio, together with the SUHFECIM team, warmly thank you for your valuable participation in this inspiring academic event. We will see you, we hope we will see you again, and tengo que decir algo. Les recordamos que este seminario se alinea al Acuerdo Rectoral de Cero Tolerancia a la Violencia de Género o cualquier otra forma de violencia y se apega a los lineamientos para promover la igualdad en los espacios universitarios. Invitamos a todas las personas presentes en este evento ingresar desde la página oficial del SUHFECIM al protocolo de atención integral de casos de violencia por razones de género en la UNAM, así como la ruta de atención para quejas por violencia de género. Thank you very much for all your participation, and we will see you, we hope we will see you soon in another work.
Thank you so much.
For the invitation and
Good night. Good night.